The basic concept about an exponent is that you multiply the base number, which in this case is x, by the amount of times that the exponent tells you to. So we would do x times x because that's 2 times. With numbers, it's a lot easier to understand. We have 3 squared equals 3 times 3, which is 9, right? We've all practiced this. Don't leave the video yet. I know this is basic, but we're going to build up our way to more advanced concepts now in this video. When you have a higher exponent, you can break it apart. Let's say we have 3 to the 5th power. Well, we could rewrite this as 3 squared, 3 squared, 3 to the 1st. All of those exponents add up to 5, and I'm multiplying each of these individual 3's. So it's 3 squared times 3 squared times 3 to the 1st. This is easier to do by hand. We know that 3 squared is 9, and then we know that 3 to the 1st is 3. So that would be 81 times 3, and that's going to be 243. So there's going to be moments in tests, especially with the SAT, where you don't have a calculator, but you have to somehow simplify advanced exponents like this. Furthermore, this is extremely helpful with radicals, which I'll explain that at the end of the video. For now, let's move on to fractions. Fractions are going to be prevalent in terms of how to simplify exponents. So for example, if we have 3 to the 5th divided by 3 to the 3rd, how can you simplify this by hand? See, you can multiply these out like we just did. We know that that would be 243 on top in the numerator, and then 3 to the 3rd would be 27. But by rewriting this with these larger numbers, it doesn't really help us by hand. So there's actually an easier way to simplify exponents when there's a matching base. We have a matching base. The base number in this case is 3. Since they're matching, what we're allowed to do is subtract the exponents. We have 5 up top and a 3 on the bottom. We do 5 minus 3, giving us 3 to the 2nd. So you subtract the exponents when you're dividing by the matching base. This makes our math a lot easier. Let's do a more advanced example though. Actually, before we do more advanced, let's flip these positions and see what happens then. What I mean by that is I'm going to put the 3 to the 3rd on top and a 3 to the 5th on the bottom. So don't make the mistake by doing 5 minus 3. We have to do the top exponent minus the bottom exponent. However, a quick shortcut, real quick, is to just put the exponent on the bottom. Put the exponent where the larger exponent is. So we have 3 to the 3rd on top. We'll just replace that with a 1 and put 3 squared on the bottom. Again, we put the 3 squared on the bottom because the higher exponent is also on the bottom. To explain this in depth, let me erase this and talk about negative exponents. So with negative exponents, the way that they function is they transition whatever term has a negative exponent to the opposite side of the fraction bar. If we have x to the negative 4th all divided by y to the 5th, nothing here really matters. The only thing you have to simplify is that negative exponent. You never want a negative exponent, and you could get rid of it by flipping it to the other side of the fraction. Understand that the y to the positive 5, positive 5th power, doesn't move to the top. Another example would be, let's do x to the negative 4th, z to the 3rd, all divided by y to the 5th. Now what happens? Well, the only thing that moves is going to be the x. So we have z to the 3rd staying up top, x to the 4th, y to the 5th. This is what negative exponents do. So when you have this example where we have 3 to the 3rd divided by 3 to the 5th, we do 3 minus 5. And that is going to be a negative 2. So what I'll write here is 3 to the negative 2nd power. But that's not good. We got to get rid of that. And so the shortcut is to just follow whatever side has the bigger exponent in it. Because you'll see you get the same result. 3 to the negative 2nd is 1 over 3 to the 2nd. If you're curious about where that 1 is coming from in my numerator, always remember, anything by itself is technically being divided by 1 at all times. We just don't do that extra step for every single number, every single digit. However, it comes in handy when you have to flip over a whole number. All right, so let's do x squared minus 3 to the negative 1st power all divided by 4x. A question might say, simplify this, and it'll give you multiple choice options. The first thing you should identify is that negative exponent up top. You need to rewrite that immediately down below. what's going to happen is multiplication. We have to distribute, however, the 4x to each of these terms inside the parenthesis. And so 4x times x squared, that's going to give you 4x to the third, and then the 4x times the minus 3 is minus 12x. Understand that this is all still below 1. And that's it. That's how you would complete this problem and simplify this appropriately. Again, this is all without a calculator, which is pretty astounding how much we could do all by hand. Moving on, let's practice more numbers with exponents, but let's throw them into fractions. So we have 3, let's do 3 to the third, all divided by 9 to the second. Now, the first thing I mentioned when we first did a fraction problem is that you need to have a matching base. We don't have a matching base here. We have a 3 and a 9. However, the 9 can be rewritten. 9 does equal 3 to the second power. This is very important. Moving on, we could rewrite the fraction as 3 to the third on top, and then 3 to the second power. This is called power to power. A very important exponent rule that does come across, that does come up very often. So when you have power to power, we have, let's say, x to the third to the fourth. What you do is you multiply those exponents together. That would give us x to the 12th. Understand, let me rewrite this one more time. We have x to the third all to the fourth power. And that's why it's called power to power. That's when you multiply. So looking at this denominator here that we just rewrote, we have 3 squared squared. All you have to do is multiply those 2's together. This top stays the same, the numerator stays the same. Down below we have 3 to the fourth now. And look, we have a matching base, and we can clearly see what we have to subtract. We have to subtract 3 minus 4. So that gives us 3 to the negative 1, or 1 over 3. Let's practice that again. This is called, by the way, change of base. Let's do 3. Now let's do something a little bit harder. Let's do 27 squared, all divided by 9 to the fourth power. 9 and 27, they don't share a base. So, for example, 27 can't be rewritten as 9 squared. But what number goes into 9 and 27? It's going to be 3. So 3 to the third power will replace our 27. And then 3 squared replaces the 9. Now we're in business. Now we could do power to power, giving us 3 to the 6 over 3 to the 8th. And doing 6 minus 8, or understanding that 8 is the bigger exponent, I just know that I have 1 over 3 squared. And that's how it's a shortcut. I don't have to do the 6 minus 8. Anyways, we have 3 squared. That's going to be 1 over 9. And that's our final answer. These are great SAT practice problems, by the way. Let's do another one. Let's do 3 squared to the negative 2 power over 9 squared to the negative 1 power. The first thing you should probably do is power to power, but just don't lose track of those negative signs. When we have 2 times a negative 2, we are going to have a negative 4. So understand you have 3 to the negative 4 power. Down below we have 9 to the negative second. At this point in time, I would get rid of those negative exponents by rewriting this fraction. 9 squared over 3 to the fourth. And now I could do change of base. So the 9 can be rewritten as 3 squared squared. And then down below we have 3 to the fourth. Excuse me. That's going to simplify to 3 to the fourth over 3 to the fourth. What's our answer, guys? It's going to be 1. A big 1. You have the same thing over itself. You're matching on the top and the bottom exactly, so it's just 1. So the last topic I want to cover is exponents that are fractions. And so what happens with this is the denominator is going to become the index for a radical. I know nobody likes square roots and radicals, but this is what happens. As soon as you see a fraction of the exponent, you need to translate it into a radical. The numerator becomes the exponent of whatever is inside. So we have x to the first power. Let's use a number to make this more relatable. Let's do 100 to the 1/2 power. The 2 in the exponent, the denominator, becomes the index for the radical. And then the 1 goes to the exponent. So essentially what this is asking you is, what is the square root of 100? That's just 10. 100 to the 1/2 power equals 10. Now I mentioned about a technique, the technique with separating the exponent into smaller exponents. That is very helpful with simplifying radicals. Let's do 4 to the 7/3 power. We have to translate this into a radical, giving us the cubed root of 4 to the 7th power. And these numbers are too big to do by hand. However, you can split that exponent into smaller ones. So we have the cubed root of 4 to the 3rd times 4 to the 3rd times 4 to the 1st. And at this point, you could then start simplifying this radical a lot easier. Again, I don't cover that in this video. I cover that in another video. It's a whole different lesson. However, as this sums up today's video, I want to mention I'm going to cover more practice problems and in fact dedicate a whole video to practice problems on exponents and exponent related questions. So if you found this helpful, please like, please leave a comment, and please feel free to recommend any other material. I'll be happy to cover that for you. In the meantime, subscribe so you can see when I release new videos and more topics. Other than that, thank you guys for watching. Thank you for supporting Path to Math. Have a great day.